We are learning regarding this hydrogen peroxide volume strength. Though this specific topic is not directly from the mole concept, it's actually from the redox reaction. So today we will be covering the redox reactions aspect as well. Before that, let's cover this hydrogen peroxide volume strength. When you look at this hydrogen peroxide, you can see this oxygen is present in -1 oxidation state. Oxygen usually will be present in -2 or 0. You can see it is an intermediate oxidation state. The oxygen is present right now. Whenever the element is present in an intermediate oxidation state, they become unstable. Here in hydrogen peroxide, oxygen, as it is present in -1 state, it is actually unstable. So when I keep it for a long time, or when I provide a little bit heat itself, it starts getting decomposed. It forms water plus half a mole of oxygen here. As we mentioned, this molarity, normality, mole fraction, etc. For hydrogen peroxide also, we have a specific term in determining or expressing its concentration. And one of the concentration term is volume strength, which is given by the symbol V. Volume strength corresponds to volume of hydrogen peroxide released from decomposition of 1 liter solution of hydrogen peroxide. How much volume of oxygen will be released from decomposition of 1 liter solution of hydrogen peroxide is called as volume strength. So if someone says it is 2V hydrogen peroxide, what does this 2V indicates? It indicates that 1 liter of this hydrogen peroxide solution will liberate 2 liters of oxygen. 1 liter of this hydrogen peroxide solution is unstable. It will decompose on its own to produce 2 liters of oxygen. So you can understand that 2 that is written in front of this V corresponds to the volume of oxygen that was liberated. Understood? We are describing this volume strength with respect to the molarity as well as normality. Volume strength is equal to 11.2 times of molarity. In the case of normality, you can see this, we will discuss about this n factor very shortly today. We understood that I can rewrite this normality in terms of molarity as well, isn't it? So I am writing this molarity in terms of normality here. If I express the volume strength in terms of molarity, I say 11.2 times of molarity. If I express it in terms of normality, I write it as 5.6 times of normality. Now in this question, they have provided you 20 V hydrogen peroxide. Calculate the molarity and the normality. 1 liter solution of hydrogen peroxide is producing 20 liters of oxygen at STP condition. That is what we understood. The question is asking what will be its molarity. We just now learnt volume strength of hydrogen peroxide is nothing but equal to 11.2 times of molarity. What is the volume strength here? 20. So 20 is equal to 11.2 times of molarity. From this you calculate the molarity here. Now if the question is about the normality, we know volume strength of hydrogen peroxide is nothing but equal to 5.6 times of normality. Volume strength is 20 here. Substitute it to get the value of normality. Do you understand?
Yes, ma'am.
Right.
Yes, ma'am.
Mritula, we just now started with this hydrogen peroxide volume strength. How do you describe the concentration of hydrogen peroxide? Just like molarity, normality terms. Okay, Mritula?
Yes, ma'am.
Yeah. So, volume strength is actually defined as the volume of oxygen that will be released from decomposition of 1 liter solution of hydrogen peroxide. If someone says it is 20 V hydrogen peroxide, it means that 1 liter of this solution, hydrogen peroxide solution, is giving 20 liters of oxygen at STP condition. So whatever is the number that is written in front of this V corresponds to liters of oxygen that is produced. Similarly, when I consider volume strength with respect to molarity, we say volume strength is 11.2 times of molarity. And if I discuss with respect to normality, I say volume strength is 5.6 times of normality. Okay, Mridula? Just copy down the formula. Now in this question they give you 20 V hydrogen peroxide. Calculate the molarity and normality. So volume strength is nothing but equal to 11.2 times of molarity. They have given you the volume strength value as 20. So just substitute it. 20 is equal to 11.2 times of molarity. From this you can calculate molarity. Similarly, volume strength is equal to 5.6 times of normality. Substitute it to get the value of normality. Okay. The next concentration term is called as gram strength. Look at this decomposition reaction that's happening here. 1 mole of hydrogen peroxide is giving me half a mole of oxygen gas. 1 mole of hydrogen peroxide is giving me half mole of oxygen gas. That means I am writing it in terms of grams quantity. 1 mole is how many grams? 34 grams, isn't it? 2 times of oxygen plus 2 times of hydrogen is 34 grams. Of 1 mole of a gas at STP will occupy 22.4 liter. What is a mole of gas here? Half a mole of gas. So it will occupy 11.2 liter here. Correct? So I understand 34 grams of hydrogen peroxide on decomposition gives me 11.2 liters of oxygen. If the questioner is telling you, if 22.4 liters of oxygen is liberated, then what is the gram strength? Just the double of it?
Yes, ma'am.
34 grams is giving me 11.2 liter. If 22.4 liter is generated, then how much gram is that? 68 gram is that. Understood, Ra?
Yes, ma'am.
Yes. In case, if I want to give the volume strength for this, what do I understand here? Since I say it is a 22.4, 34 grams will give me 11.2 liters of oxygen. Correct, Ada? 34 gram is giving me 11.2 liters of oxygen at STP. So what have we learnt? 1 liter solution of hydrogen peroxide will give me so many liters of oxygen at STP condition. Correct?
Yes, ma'am.
Yeah. So if I am talking with respect to 11.2 liters of oxygen that I have collected with STP, I will say that will be its volume strength, isn't it?
Yes, ma'am.
Right. Let's go for the next question here. We will solve this question. Solve this question. Have you solved it?
Doing, ma'am.
Okay.
Ma'am, it is 0.30.
That's right. Very good. That's right. Correct. See here, they are taking 15 ml of 20V hydrogen peroxide. The moment I see 20V hydrogen peroxide, what do I understand? 1 liter of hydrogen peroxide will give me 20 liters of oxygen. Correct? They have taken only 15 ml. So if 1 liter of hydrogen peroxide is giving 20 liters of oxygen, what about 15 ml of hydrogen peroxide? 15 into 20 into 10 power minus 3. Correct?
Yes, ma'am.
Right. Let's go to the next question. Amount of hydrogen peroxide present in 1.5 normal hydrogen peroxide solution. Which chapter are they teaching you now, Nitish?
They completed atomic structure, ma'am. Like they didn't start anything new. They completed mole concept, atomic structure, and gaseous state.
Oh, you completed gaseous state also.
Yes, ma'am. Today there was an exam on this, ma'am. Tomorrow also.
On gaseous states.
Like all three chapters.
Oh, all the 3 chapters. So did you learn something new from atomic structure chapter other than what we taught?
They like gave us questions based on Schrodinger gravitation or something.
Okay. I think we didn't complete Schrodinger equation, isn't it?
Yes, ma'am.
Ma'am,
Yes.
ma'am, did you complete a revision of organic chemistry from the previous batch?
Which one, Ra?
Um, like revision of that organic chemistry, like I completed till alcohols and carboxylic acid. Ma'am, did you teach extra other from that?
Right now I'm doing aldehydes ketones and
Ah,
carboxylic
okay,
acids.
ma'am.
Okay, guys, you completed? Did you get this answer? You need not go with volume strength formula and all. Just go with the formula. Normality is equal to equivalent moles divided by volume of solution in liters. Normality is 1.5. Equivalent moles is weight divided by equivalent weight of volume of solution in liter. They are asking for this weight. What is equivalent weight? Molecular weight divided by n factor. The molecular weight of hydrogen peroxide is 34. The n factor of hydrogen peroxide is 2. Okay, so just substitute it. Volume is 1. Get the value of weight of hydrogen peroxide here. Okay.
Okay, ma'am.
We are talking about the final way of expressing this hydrogen peroxide. 3% hydrogen peroxide is equal to what will be the volume strength of hydrogen peroxide here? I repeat, you are provided 3% of hydrogen peroxide solution. The questioner is asking you to find out the volume strength of hydrogen peroxide here. 3% is nothing but 3 grams in 100 ml of hydrogen peroxide solution. 3 grams that is present in 100 ml of hydrogen peroxide solution. But right from the beginning, we are discussing this hydrogen peroxide volume strength in 1 liters, right? But here it is in ml. So I am trying to convert it into liters. If 3 grams of hydrogen peroxide is in 100 ml, then in 1 liter, how many grams of hydrogen peroxide will be there? 30
30.
grams. So 30 grams of hydrogen peroxide will be there. Now the question is asking for the volume strength. Volume strength will be expressed in terms of the oxygen that is liberated. We know that hydrogen peroxide will give me half a mole of oxygen. That means 34 grams of this hydrogen peroxide will give me 11.2 liters. How much grams I have got here? 30 gram. So 30 grams of this will give me how much liters? In a calculated, approximately it will be 10. So I express it as 10 volume strength of hydrogen peroxide. Understood?
Yes, ma'am.
Right. The next concept